Here I am in the Halo 3 editing kit directory. The first thing we want to do is run tool.exe. However, tool.exe is not your typical graphical user interface program. It is done through the command line, so in order to get that running, you go up here to the address bar in your h3ek directory. You highlight the text here, and you type cmd and hit enter, and that should bring up the command prompt. Here, after this, what we want to do is that we want to find the model that we want to get. So this will work for not only characters, but it will work for weapons, vehicles, in theory, pretty much anything that is a render model. So we'll go to tags. I'm going to do a grunt, so I'm going to go to objects, characters, and grunt. And this is finally the place where I want to be. So now we will run tool. So we type in the command prompt, we'll type tool to specify that that's the program we want to run, and then the command, the tool command we want to use is going to be extract hyphen import hyphen info. So that's the command. Now this command works for not only render models, as this one right here, but it also works for physics models and collision models, as well as scenario structure BSPs. But for now, we're just going to do render model, and we want to get the path to the grunt.render model. Now, since we're already in the h3ek directory here in the command, we only need to start from tags. So we'll start that with a quotation mark and type tags slash objects slash characters slash grunt slash, and now we need to specify the file that we want to extract, which is the grunt.render slash or grunt.render underscore model. So I'll type grunt.render underscore model and then close that with another quotation mark. Now we can press enter, and there we go. Tool has done its job. You can see right here on this line, it says done data slash object slash character slash grunt slash render slash grunt underscore standard.jms. That is where it put our extracted.jms file. I am going to show you the physics model and the collision model just to show you what that looks like as well. So I'm going to go, I'm going to press up, the up arrow key on my keyboard, and that will give me the exact same command that I typed in last time. And I'm just going to replace render model with physics model, extract that. It has extracted in a similar directory as grunt ragdoll.jms, and I'm going to also export the collision model. So I'll press up on my keyboard again, and then replace physics model with collision model. Hit enter, and there we go. That has exported as grunt underscore collision.jms. So now this is pretty much ready to open up in Blender. I am going to do one thing to make things a lot easier for myself though, and we can close out of the command prompt right now, so can get rid of that. So keeping in mind the directory it told us, that is back in the root directory. We're going to go to data, objects, characters, grunt, and then we have a folder for our collision model, physics model, and render model. However, I'm going to go back to the data directory, and I'm going to just move this folder to my desktop. So I'm going to cut it and paste. The reason why I'm doing this is just to make things easier to access in Blender. So I'm going to open up Blender, and once it's ready, we'll just delete everything from the scene. We can get rid of the timeline as well. Now, in order to actually import that .jms, you of course do need the, let's see, you do need the Halo Asset Blender Development Toolset. So make sure you have that installed. And that will give us the import options and export options that you will ever need for modding Halo. So I'm going to go to import, and we're looking for Halo jointed model skeleton.jms. I'm going to open that, and of course I saved it to my desktop. So I'm going to go to desktop, and then it's that objects folder, character, grunt. Now I'm going to do the render model first. The render model is the actual graphics of the character itself. It's what you see in the game. Physics is for like ragdoll effects when the character dies, and collision, I am pretty sure, is the actual hitboxes in the game that tell, you know, that make it so that the game engine knows you get a headshot is if they get hit with that head collision box. So I'm just going to do render first, and then I have grunt standard.jms. One more note to make here before we import is that under game version, it says auto. You can leave this as it is, but since I know it's Halo 3, I'm just going to change it to Halo 3 and import. And what do you know? We got a grunt. And we not only have the model itself, but we have the armature. So let's try posing the armature. It's not working. Well, you're probably thinking to yourself, what the crap? Well, the thing is that when this armature is imported, the mesh is parent, or the armature is parented to the mesh as it should be, but it's not actually parented correctly. It's parented as an object. So in theory, if I move the armature around in just object mode, then the mesh will move with it. But when I try to pose, it won't pose. And to drive this point home even more, you can see here, if I take a look at the bone names, you'll see for, okay, B_R_thigh. And if we go to the mesh and we go to the vertex groups are where the weights for each individual bone are stored. You can see that they have the same names. You might also be thinking that, well, maybe these are empty groups. And they actually aren't, because if I go into edit mode and I select this vertex group and I hit select, you can see that in fact vertices are selected. They are weighted, and you can see that here in weight paint mode. You can see that it is in fact weighted. So what's the issue here? Again, the issue is that it's parented, but not parented in the context that it's, you know, that of a context of it being an armature. So the easiest way to fix that is first select your grunt model and then shift select the armature. So you should have this dark orange outline around the grunt mesh and then a light orange outline around the armature. Next, you go to object and parent, and then you want to do armature deform. Make sure not to, you don't need to select any of these three. You don't need to do with empty groups, with automatic weights, or with envelope weights, because the weights are already set up. So you just need to do armature deform. And now we go back to our armature and we try to bend, then you can see that it is working as it's supposed to. The bones are bending. You can make the grunt tap his foot, do the stanky leg if you wish. One acknowledgement I want to make that I forgot to mention after I finished recording is that there is currently an issue with the importer, the JMS importer. If you go into edit mode and you try to select a full section of the mesh, it only selects each individual polygon. And again, that is currently an issue with the importer itself. It's just every polygon is separated from every other polygon. One more thing is that you have these spheres here on the armature. These are just points for the game engine to know where to put effects like gas coming out of the gas mask, or right hand. You know, this is where a grunt will hold their weapon, or I think right hand, or these feet one might be used for inverse kinematics. I don't know that for certain. And I don't know if these are ever used in the game itself, but here's a thing for weapon thigh to, I guess, carry a weapon, like a secondary weapon. Also, if you want to fix the face segmented issue where, you know, all of these are just separated polygons, you can do this. Just select all of the vertices and do mesh, merge by distance. And that'll remove quite a bit of vertices. There are some cases where you may not want to do this. Let's see. So, for example, like this backpack, it is a separate mesh from the body. There may be some instance where you have vertices that are just close enough together on separate, what are meant to be separate meshes, to where Blender will merge those together, and then you won't have separated meshes like you're supposed to. Just a heads up, that is something that might happen, but that is an option where you can merge the vertices together. So yeah, we pretty much have our entirely rigged model. Now you can stop here. However, you may want to apply the actual textures to the grunt. This is a personal preference. You don't need to do this step, but if you go to Material Preview, there's no textures. And that is because the textures are in the bitmap file and not the JMS file. So how do we get the textures for our grunt? Well, we go back to our Halo 3 editing kit root directory, and we need to run tool again. Now, the first method I'm going to show you actually doesn't work. I can't get it to work for whatever reason. I'm guessing that it's just broken. But I want to show it to you anyway, just so you know that it's there, and yeah, just for completeness sake. So we need to run tool again. So up here, you know, open it the same way we did last time, command. Now the bitmaps we want to look for are in that same tag folder. So tags, objects, characters, grunt, and then we want to go to the bitmaps. And here are the bitmaps. These bitmaps contain the image textures that we can apply to our grunt model in Blender. So the way you're supposed to do this is by, again, using Tool, and there are a group of commands in Tool called export bitmap hyphen, so you put hyphens between the words, and there's 3 of these. So there's 3 different versions to this command. There's TGA, DDS, and some other format that I was not familiar with, and I could not get any of these to work properly. But I will show you TGA, so export hyphen bitmap hyphen TGA. Now this command wants the path to the bitmap, that tag that you want to extract the textures from. So again, that will be tags / objects / characters / grunt / bitmaps, and then you just type in for whatever one, you just type the name of the file. You don't add the suffix, because it's already assuming that you're doing a bitmap. So type in grunt without the .bitmap, and now it wants you to specify the output path. So you do a space and then do another quotation mark, and you do another path. So I'm just going to do it in the same path as this, the same directory as this. So tags, objects, characters, grunt, bitmaps, and grunt again. Again, you don't have to add the .tga extension, because it already knows that it's going to do a TGA. Press enter. Okay, so this is an error that it has given me every single time that I've tried to do this. It gives me an error, failed to decompress, some hex code, invalid, attempting to save directly, and yeah, it doesn't do it. So it gives you this garbage file that you can't load. Yeah. So that's that. So I'm just going to delete that. So since this command isn't working, what's the solution? The solution is to use Reclaimer. Reclaimer is a community tool right here. I'll open it up. Now, first thing is that you want to make sure that you are running the most recent version of Reclaimer. Otherwise, you'll run into just endless problems. Just update. You'll know that you have the most recent version if this is blue and it says ready. If it's purple and it says an update is available, then go update. So we want to open up a map, a .map file that we know has a grunt in it. So pretty much most campaign maps. So file, open map. You'll want to go to your install directory of Halo the Master Chief Collection. For me, I have it installed on Steam, so I'm going to go to my Steam apps. And once you're there, Halo 3. And then maps. So I'm going to pick 010_jungle because that is Sierra 117, and we do know that that has grunts. Open that up. Once it is open, you get a list of all these folders. Gonna go down until you see render model. That's pretty familiar, isn't it? You go down until you see characters /grunt/grunt. Open that up, and here we have our full grunt model fully textured. Now to export the textures, we can click here on Export All Bitmaps. And I'm going to export it to the folder that I exported the render model to. I'll select that. And it is done. So I can just close out of Reclaimer now. We're done with Reclaimer. Open up Objects, Characters, Grunt, Render. And now we have two new folders. We have Shaders and Objects. You can get rid of Shaders. Don't need it. Objects, you want to go to Characters, Grunt, Bitmaps, and then these are really the 4 textures right here that you want. Don't really worry about skin detail bump, because those textures really only apply for like Halo 3 shaders. So let's just cut these and paste them with where our grunt standard JMS is. And with that, we can delete the objects folder. Okay, we now have grunt.tiff, grunt underscore color correction, grunt illumination, and then grunt zbump. Zbump is, of course, the normal map. Color correction is used to give grunts their varying colors, like red for grunt majors, orange for grunt minors, white for ultras, green for heavies. So you really don't need to use this one unless you really absolutely want to. I'll show you how to get all these textures in. So let's go back to Blender. And we want to select our mesh. And next we want to go to the Material Properties panel. This will have all of the materials. And another thing we want to do is open up a shader editor window. And of course I did that by just dragging up to create a new window, dragged up on the corner. Okay, so of course we want to use nodes, because otherwise we can only give, these are the only options here for our material if we don't use nodes. So use nodes. And once we have that, once we have that, we can drag in, go back to where this folder is, and we can drag in all of these image textures now. Did that only do one? Okay, it only did one for some reason. That's okay. This is the base color. The grunt.tiff is the base color. So we'll just plug that into base color. And as you can see, it's already working. No UV unwrapping required, because this JMS file is also exported with the UV maps. Okay, next we'll do illumination. We'll come back to CC later. And illumination, of course, will go into emission. That is the lights on the model. So I believe this blue spot right here is a light. You can see that that's how that will work. And if I go into rendered mode, you can see that that portion's lit up. Next, we are going to do the grunt Z-bump. When you import this one, you want to change color space from sRGB to non-color. That will give you the best results when using a normal map. And before we plug it into normal, we actually need to get a vector normal map node. And then we can plug in our color and plug that into normal. And now we're getting those normal map details. Now I will show you how to do the color correction. This is kind of a rough way to do it, but it gets the job done. Bring that in, and you want to mix the base color texture with the color correction. So let's do mix RGB. And so this will be in color 1. We'll do color correction into 2. Yeah, that looks pretty good, I think. It's hard to tell. We won't really know for sure because this is on a portion of the grunt that isn't really colored. So let's go ahead and let's apply this node tree to all of the other materials. So the easy way to do that is select all of these nodes. I'm going to press B on my keyboard and select all of these nodes and do Control C to copy. Next, go to Grunt Armor. We'll want to hit Use Nodes again. You can delete this node and Control V, and that will give us our exact same node tree. Now you can see the color. So let's mess around with this. If we do mix all the way up, then that is going to pretty much get rid of a lot of these more grimy details. So we actually, I believe we want to do add. And the reason we want to do add is we don't want to do multiply, because when you have black areas in the color correction texture, that is going to just make those areas black. So let's just do add. Let's turn it up all the way. And yeah, that looks good. Let's change that with our other material here. So mix, change that to add. Turn the factor all the way up to 1. And I'm going to just select all of these again, Control C, use nodes on these other two, paste them in. Looking good. Use nodes. Okay, so we now have our fully textured grunt. Again, this is not a step that is required if you want to animate this model, if you want to do anything really with this model, but it's mainly just for preference, especially if you do want to adjust the UVs for any reason. Let's see what else we can do with this color correction. You may not want your grunt to look to have this red color. So what we can do is that we can add color, and let's just do hue saturation. And we can change hue, the hue factor. And I don't know why that's not doing anything. Oh, I know why. Because I'm not on the I'm not on that same node tree. Let's do that again. Color, hue saturation. And now we can change. So now you can have a green grunt, red grunt, purple, blue, whatever you want. You can, of course, change the saturation to have a white grunt. You can change the value to make it darker. So yeah, pretty cool stuff. Okay, so that pretty much completes it, except I do want to show you one more thing. But before I do, I should specify the reason why I didn't just get rid of all these materials and instead edited them one by one is because it is important that you do keep the names and the amount of materials, because the Halo game engine looks to see for, how many materials there are, and it does use these material names when applying shaders. So yeah, you do generally want to make sure that you keep these materials intact. Okay, so we did export the collision model and the physics model earlier as well, and I will show you what that looks like. So we'll do File, Import, JMS again, because they are still JMS files. We'll do the physics one first. So let's import that. That didn't import like it was supposed to. Let's try that again. I'm going to do all of that unselected. Physics, ragdoll. Huh. Well, I don't know why it's giving me an error right now. But since it is, let's try the collision. Alright, so the collision came in fine. Now you'll see the collision is a very far lower poly model, and again, I believe that the collision model is what is used for applying damage when a bullet travels and it hits this block on the collision model. That's how it knows that it landed a headshot, versus if it hits, you know, on the arm or on the body, it is not a headshot, of course. And another thing I want to point out is that both the collision model and the physics model share the exact same armature as the render model, which you can see here if I select the armature. Now, you'll see that it's very hard to see my armature because it's clipping through the model. So to change that, I'm going to go to this green stickman and go to viewport display. Change that to in front. Now I can see all my bones. Now go to pose mode, and if I move this, it should move. It's not, because we are running into the same issue when we imported the render model. So again, we need to select the collision model, then select the armature, object, parent, armature deform. Now, when we pose, it's working as expected. And again, that is because the collision model shares the same vertex groups as the render model. And again, this same thing with the physics model. I'm going to try to import that in a different blend file. So, import JMS. Grunt ragdoll. Now it imported correctly. And of course you can see it's the same armature, same exact armature. And the ragdoll model is just, you know, very rudimentary shapes. Because again, I believe that the ragdoll model is what is used when the character dies, and the game engine knows how to collide the different body parts with the world around it. But there you go. That's how you import any rigged model from the Halo 3 editing kit to Blender.